Hi students, welcome to my Abhyas. Good morning. My name is Dr. Radha. I am your chemistry teacher. So in this session 3, now I am taking you people to the discussion close packed structure. In my previous discussion sessions, we discussed about what do you mean by solid, types of solids, types of unit cells, and then number of atoms in the unit cells. Then about crystal lattice also we have discussed in detail, and how to calculate number of atoms in unit cell also we have discussed. I hope you understood all those things, right? Okay. Now let's have a look at that concept, that is close packed structure. See now, what is the meaning of close packed structure, that we are going to have the discussion here. Already we discussed in the very first session that crystal means it will have a regular close packing arrangement, right? So what do you mean by that? In a crystal, so constituents, what are the constituents usually? So we told atoms, ions, or what? So molecules. Yes. So these are known as what we call it as a constituents, right? So here the constituents are closely packed. Constituents, when they closely packed, so what is going to happen? It will act as a perfect crystal. So now what do you mean by close packing? See, this is a minimum space. Example, you consider this is the minimum space that is available for me to arrange the constituent particles, like that, to assume this is the minimum space. In this minimum space, maximum number of constituent particles are closely packed like this. So in the available minimum space, I have arranged large number of what exactly? Constituent particles in a close mannered form. So this type of arrangement where maximum number of constituent particles are accommodated in the minimum space. Okay, so that type of arrangement we can call it as a close packed arrangement. And the structure where you will come across this type of arrangement can be termed as what you call it is a close packed structure. Now, what do you mean by a close packed structure? Means it is a structure in which in the available minimum space, maximum number of constituents are closely arranged in a ordered form. That type of arrangement is known as what we call it as a close packed structure. I hope you understood this, right? Okay. Now, I'm going to take you people in detail discussion now. So, as I told, here the solid particles are closely packed. Now, for example, take, see now the constituent particles I am writing here. Look at here. You assume this is the central constituent particle. Okay. For example, with respect to this structure I am telling now. Now around this central atom, so how many nearest atoms are there? 2. I mean this particular central constituent is touching to 2 neighboring constituents. So this we call it as a coordination number. So whenever a close packing arrangement takes place, there we will come across the terminology coordination number. Now what do you mean by coordination number? Number of nearest neighboring particles around the what exactly? The central atom or central constituent. That we call it as a coordination number. Now I am taking you people into the concept of what? Coordination number. Now, what do you mean by coordination number? So let us have a discussion here now. See now, coordination number means the number of nearest neighbor. Okay. So number of nearest neighbors of a particle in the crystal is called the coordination number, as I told you people, right? Now here you can arrange constituent particles along x direction, y direction as well as along z direction also. That means here even on 1 dimension, 2 dimension and then on 3 dimension we can arrange the constituent particles. Okay, so how we are going to arrange the constituent particles, whether only in 1 direction or in 2 direction or in 3 direction, we can have the arrangement in 3 ways. Okay, students, so how we are going to arrange the particles, whether on 1 direction or in 2 direction or in 3 direction, you can classify this close packing arrangement into 3 forms. One is known as 1-dimensional close packing. Second one is 2-dimensional. Okay students, based upon the direction in which we are going to arrange the constituent particles, we can classify this close packing arrangement into 3 types, you know very well. If we arrange only in 1 direction, we call it as a 1-dimensional arrangement, right? In 2 direction, if we arrange, that is along x-axis and along y-axis, we call it as 2-dimensional arrangement. Along all the 3 direction, if it is arranged, then we call it as a 3-dimensional arrangement. Now, we'll discuss one by one in detail. Now, let us take up our discussion to 1-dimensional arrangement. What do you mean by 1-dimensional arrangement? See, packing in 1-dimensional arrangement. What do you mean by that? Please look at this diagram here. These are the constituent particles. For example, I am writing constituent particle as A here. This A indicating the constituent particle. It may be atom or molecule, anything you can assume. For example, you assume atom. A stands for atom here. Now, all the atoms are arranged only in 1 direction, or else in general, what we can say, all the constituent particles are closely packed along 1 direction. Such type of arrangement, we call it as close packing arrangement in 1 direction or 1 dimension. So now, what do you mean by close packing in 1 dimension means here there is only one way of arranging the constituent particles. Here the constituent particles I am representing by a solid sphere. This is a solid sphere. So this solid sphere stands for what? Constituent particle. Okay. So all these solid sphere that I have considered as a constituent particle are arranged closely along only 1 direction. So such type of arrangement we call it as close packing in 1 dimension. So this is the first type of what exactly close packing arrangement. I hope you are understanding. Now please look at this picture. What happened here? This, for example, if I consider this as a central sphere or central constituent particle. Now around this central constituent particle, see here, this is the one constituent particle, neighboring constituent particle to this central one, and this is the another, what exactly, nearest neighboring constituent particle, right? So here this is central constituent particle is in touch with the nearest 2 neighboring constituent particle. So here for the 1-dimensional packing arrangement, then I can say coordination number is how much? 2. So now that's what for 1-dimension close packing the coordination number is 2. So like this, how many number of nearest neighboring particle touching to the central constituent particle, based upon that you can assign the coordination number. Okay. Now for 1-dimensional close packing arrangement we can assign coordination number as 2. Okay. So like this is all about close packing in one dimension. I hope you understood, right? Now, I am going to take my discussion to close packing in two dimension. What do you mean by close packing in two dimension? See here, close packing in two dimension. See, I am going to abbreviate CP. CP stands for close packing in two dimension. What do you mean by this? See here, for example, you please look at this arrangement. So now I can arrange constituent particles, layer of constituent particles vertically as well as what? Horizontally. Right? So along y-axis also I am arranging constituent particles. Even along x-axis also I am arranging constituent particles. So this is a one row. This is a row which is arranged along x-axis. That row I am considering it as a. Next, another row of constituent particle that I am keeping on the what exactly? The first row. Like that, one particle of the second row is just above the particle of the first row. So almost this arrangement is similar to the first row. That's what. If I consider first row arrangement as A, then second row also, because it is similar to the first row, that's what I can assign the second row arrangement also as A. Then one more layer, if it is placed just above the second layer, then I can consider it as again A. So what happened here? The constituent particles are arranged in two directions, vertically as well as horizontally. So such type of arrangement, we call it as what we call close packing in two dimension. So close packing in two dimension means the constituent particles are arranged vertically as well as horizontally. So that we call it as what we call close packing arrangement. Okay, in two dimension, the constituent particles are arranged. So now here, this type of arrangement where all the constituent particle rows are similar to each other, we call it as AA type arrangement. So what do you mean by AA type arrangement? Means it is a type of close packing arrangement in two dimension. So it will form. So there all the rows are arranged similar to one another. So that type of arrangement we call it as AA arrangement or AA close packing arrangement. I hope you are understanding, right? Now, please look at this. Now, if I consider this as a central constituent particle. So now I am considering this as a central constituent particle. Okay. Now, please look at this diagram. Carefully you observe. Now here, what happened? Around this central constituent particles, how many constituent particles are nearest to the central? I mean, how many constituent particles are touching to this selected central constituent particle? Please look at this diagram. So this is the one constituent particle or a hard sphere. That hard sphere I am considering it as a constituent particle. So this is touching to this central selected, and this is the one, another one from this row. This is also in touch with the selected central one. Similarly, this is the one that is also in contact with this central selected one, and from this row, this constituent particle or hard sphere. So this is in touch with this central, right? Now here, how many constituent particles can be considered as nearest neighbor touching particles to this central one? Means 1. See, I am going to write now 1. This is the 1, and from this here 2 and 3 and this one 4.